I built Hummingbird, an open-source runtime that makes massive mixture of experts models practical on consumer hardware. I built Hummingbird, an open-source runtime that makes massive mixture of experts models practical on consumer hardware. What if your laptop could run models with hundreds of billions of parameters? That is exactly what Hummingbird is trying to do. The creator was just shared this project on the open-source subreddit, and it tackles one of the biggest bottlenecks in modern artificial intelligence: memory. The approach is both ambitious and practical for anyone working with large models on limited hardware. The frontier open-weight models have grown past the point where they fit in the memory of an ordinary machine. A model with hundreds of billions of parameters needs far more random access memory than a laptop or a single consumer graphics card can offer. The traditional approach has been to either need expensive enterprise hardware with massive memory pools or sacrifice model quality by using smaller models. Hummingbird takes a different path entirely by changing how the model is placed across the storage you already have. This is the core insight behind the entire project. Hummingbird is a lightweight zero-dependency runtime written in C17 for running massive open-source large language models, both dense and mixture of experts, on consumer hardware. The creator describes it as treating solid-state drive, random access memory, and video random access memory as one unified memory hierarchy. Instead of keeping everything resident in memory, it streams experts on demand. The project is still in early foundation status and is licensed under Apache 2.0. It was designed specifically for research and experimentation with large, sparse models. The goal is to let a machine with modest random access memory run a model whose total size dwarfs that memory. The engine organizes weights into two classes. Weights needed for every token, like attention and embeddings, stay resident in fast memory. The large pool of routed expert weights lives on disk and moves up on demand. There is also a learning cache where repeated workloads keep the right weights warm. The creator says the engine gets faster the more it is used. Coalesced streaming pulls expert weights efficiently from storage, reducing latency when switching between different expert pathways in the model. This means that as you use the model more, it learns which experts you need most and keeps them ready for the next request. Built-in portable C with no third-party runtime dependencies, it needs no BLAS and no Python. You can build with GCC, Clang, or MSVC on Linux, Mac OS, or Windows. The build system uses CMake version 3020 or later. There are build options for CPU backend as the correctness baseline, CUDA backend for NVIDIA graphics cards, and Metal backend for Apple Silicon. There is also a test suite for validation. The project includes a one-liner installer for quick setup on Linux and Mac OS systems. You can even build from source with just a C17 compiler and CMake. No other runtime libraries are required. The project supports several large open-weight models including GPTOSS 120 billion parameters, GLM models, DeepSeek, QN, and Gemma. The creator built a custom HBM format for storing model weights optimized for Hummingbird's streaming architecture. You can run one-shot text generation with a simple command, start an interactive chat mode for conversational use, or launch an open AI-compatible HTTP server for programmatic access from other applications. The CLI tool is called HB and supports multiple modes. The serve command lets you expose the model over HTTP on a configurable port. The run command accepts a model path and a prompt for quick inference. When the post appeared on the open-source subreddit, a commenter named Goxie noticed that the license mentions the project is based on Calibri. They asked what extra Hummingbird adds on top of Calibri. The creator, responded that they wanted to be transparent about that from day one. The goal is not to recreate Calibri, but to build on the same core ideas and evolve them into a more general-purpose runtime. Hummingbird is designed to support much larger mixture of experts models beyond GLM with smarter streaming and a more modular architecture. The creator also pointed out that inference is still in active development and they are seeking community feedback. The project is currently in early foundation status, with inference still in development according to the README. The creator explicitly invited feedback on the architecture, documentation, and implementation from the community. The repository is licensed under Apache 2.0 and currently has 39 stars. It is still very new, but the creator has been actively working on the project. Another commenter asked about the HBM format and whether GGUF models work, which is a fair question for anyone wanting to use existing model weights. The creator has not yet confirmed GGUF compatibility, but the custom format is designed for optimal streaming performance. The project repository is still growing, and the creator is actively responding to community questions. That wraps up our look at Hummingbird. If you are working with large language models on consumer hardware, this is definitely worth keeping on your radar. The unified memory hierarchy approach could be a game changer for running massive models without enterprise gear. Check the link in the description to try it yourself. Thanks for watching, and let us know what you think about this approach to large language model inference in the comments below. Subscribe for more deep dives into open-source artificial intelligence projects. That wraps up our look at Hummingbird. If you are working with large language models on consumer hardware, this is definitely worth keeping on your radar. The unified memory hierarchy approach could be a game changer for running massive models without enterprise gear. Check the link in the description to try it yourself. Thanks for watching, and let us know what you think about this approach to large language model inference in the comments below. Subscribe for more deep dives into open-source artificial intelligence projects.